Yeah, my name is Christian Goll, and I will talk about Kowalski, the helpful AI assistant. If you didn't hear anything before about Kowalski, the reason for this is I started this project 2 months ago, so it's a relatively new and emerging technology. Yeah, and it's the obligatory AI talk here at the conference. Yeah, I will talk short introduction about the tools I'm using and then how Kowalski is using this kind of tools. Um, at the moment, we know LLMs are out in the wild. People are using it. We have these large language models, and they are really powerful to do. You can ask them anything. You get sometimes really helpful answers, sometimes not, but they are there. That's a matter of fact. I'm pretty sure that people are using LLMs to configure their system. So they will ask simply an LLM, yeah, how do I configure this? How do I configure that? For example, I want to run an Apache. I want to import a certificate. How do I do this? These are most like, I don't have, I'm pretty sure people are asking these questions. Still, we at SUSE and OpenSUSE will face the problem that, for example, if you ask an LLM, yeah, I want to install Vim, then it will tell you, yeah, you have to use DNF to install Vim, and that's definitely the wrong answer. So here, that's an example. I just ask with a standard prompt. Here it's the DeepSeek model. Yeah, I want to install Vim, and but here you see it tells me, yeah, okay, if you're on Ubuntu, you have to use sudo update. If you're on a Fedora, RTL, or whatever, then you have to use yum or even DMF. So it does not even know, yeah, what's now here an older RTL CentOS. Or if you are on an Arch, then you will have to use Pacman. But in the last, for us, the right answer comes at last. It's, yeah, you simply super to install them. That's the thing. And the user then has to select here the right one to get his task done. You can also, for example, if you would, if the LLM asks, yeah, I want to configure my firewall, you will have to give it your firewall, actual firewall configurations. You might leak sensitive information. The reason for this that the LLMs cannot really do that task, they are most likely able to do is that they miss the context. It's like here, Jon Snow, when he's behind the wall and Igor tells him, you know nothing about it. So that's the thing where the LLMs finally are really struggling. They know nothing about the system and what they are doing to. They don't have any context. And so what we need is somebody like this guy who only had the qualification. He knew things. He couldn't do anything, but he just knew, okay, we have this and that, and that's the guy we need to bridge this gap where LLM fails at the moment, and because it doesn't know your system. And also the thing here I'm wondering is that it should be easy to get out the information of the system. So we have so much context when we just have a binary running the system. We have the context. Yeah, we know exactly. We just have to parse the OS release to know, okay, you are on a SUSE system. You have to use zipper. Then we can get access to nearly every file on the system. We can get access, for example, if the user wants to install Vim, we could even check, yeah, is Vim perhaps already installed on the system or not? And we should tell him how to use it. That's the thing. And that's the basic idea of Kowalski is it's designed to bridge exactly that gap. It provides the LLM with the context. So, and the name Kowalski you see here, that's this penguin. It's from the movie Madagascar, and it's not really nice. So he's always slapped around. So, and that's the basic idea. So you get it. I want to have an assistant I can slap around and say simply, yeah, I want to enable the SSH server, and I don't know how it's called right now, or I want to enable the HTTP server, or I want to, for example, a thing I'm always struggling is the firewall. I want now my firewall set up, open that port, running on that specific network device. Yeah. And one thing what to bridge this is that we have on the one hand we have accurate information of the system, and on the other hand we have the documentation which is created by SUSE and by OpenSUSE, and there we have the information we want to know. So, and now we have to connect these two things. And for that, that's another technique we have now in the AI space. That's the so-called vector embeddings. Now, that's a short excursus of what's a vector embedding. A vector embedding is that we have tools where we can map every sentence we have to a fixed vector in a high-dimensional vector space. And the key property, and that's always the example, is that you can do then arithmetics in the vector space. So you have the vector which is pointing to king, you subtract the man vector, then you add the woman vector, and then you are in the near of queen. Okay? And we also then similar items cluster together in that highly dimensional vector space. So it's most likely more than some 100 dimensions. So I think the one I'm using actually is 762 dimension, which is really, really big. And here's another, yeah. How do you get to that vector spaces? There were a topic of long research. So at the start, you have this simple models, and then I think 4 years ago, Google came up with this Word2Vec, where they then also used a neural network to create these vector embeddings, and they just kind of parse Wikipedia, and then from there they get their vector the vector embeddings. One thing is also that if you have done a little bit of physics or mathematics, you know, a high-dimensional vector space, calculating distances there, it's not that easy as it looks like, but the good answer is that Facebook has solved this problem, Meta has solved this problem by a library, and this can be easily used. So you just say, okay, if I get an embedding, I can ask the library, yeah, what's the nearest vectors to, what's the nearest other vectors to it, and then so I can get back the relevant documentation. Yeah, that's now the conclusion, and here is an interesting kind of projection of this nomic embedding I'm using. Well, these similar things you see, for example, here sports classes together with football tournaments. But we should not see too much out of this projection because it's complicated. Right, so we are using this embeddings. So we create embeddings for every document in the documentation we have. And so we can then map back the question. So then we create an embedding for the task the user asks. And then we can extract the documentation we have. That's the 5 nearest one. And then also check, for example, what we are getting back. And this embeddings itself, they are also available like the LLMs with different dimension, OSS licenses, text length, so they differ in kind of how long the question or the task can be. So there I still have to choose the right one. Okay. And then how do we run this? So we can all run this on Ollama, which is an AI tool where you can on the one hand run the large language model, and the other thing the embedding model. Ollama, it's a relatively new technique, which are also relatively new. I think it's 4 or 5 years old, and it came out when the Llama model, the weights from the Llama model from Facebook leaked, and then people found out that you can quantize these models, which means the original model, it was 32-bit, but you can simply map the vectors to 16-bit or even just 3-bit. And now, I think 3 weeks ago, Microsoft came out, you can just have, you can also, with the right thing, you can map in to -1, 0, and 1. So it's a trick, I think. And the model still gets you good answers. They are not as good as you use the full precision, but they are good enough. And that means you have much smaller models. You can suddenly run your models on a CPU, and you do not need that expensive GPUs anymore. It's just a minimal accuracy loss. Yeah, that's exactly. Then another thing, why then I used Go to implement Kowalski, it's because unfortunately I also packaged some of the Python AI libraries, and these Python AI libraries, they always have a long end of other libraries they are importing, and you just see at runtime that the Python library you are using to connect your to do anything will then pull another Python library and pull another library, and also that's a thing I just didn't like. Yeah, I wanted to escape this dependency hell of Python. And there's another. So with Go, you just have that single binary you have, and all this kind of dependency hits you at compile time and not at runtime. So the developer, which is just me at the moment, has then to check which library he's importing and which not. So now, how does Kowalski work? That's a really interesting part. So as exact, the user asks a question or a task. Then I create Win. I send this task to Olama, which gets the embedding vector. Then I get the embedding vector back. And then with that embedding vector, I can search my local database, what documentation matches the task at best. Then I extract that documentation document, check if there are any files mentioned or any comments mentioned. Then if there are files mentioned, I will simply check, okay, is this file present on my system? If it's present, I will simply read it out and then kind of get the files in the state. And then I can get the task or question back with the documentation, with the actual state of the system, back to the LLM, give it the LLM as context, and then I just present the answer from the LLM. What's not happening yet is a post-processing of the answer. That's perhaps a thing I want to do. For example, I instruct the model, if there's a specific comment the user should do, then I put it in circular brackets and write comment before that. Then I could pass out and just say, yeah, okay, press 1 to run that comment on your system. There's also the thing why I'm running here the separate Olama instance, because it's easy to set up, it's there. Then I don't have to care in Kowalski about GPUs and accelerations, because that's all done in Olama. Olama also has a lot of, takes care of downloading the LLMs. It takes care of downloading the embedding models and things like this. You can run Olama on your local machine. You could even run it somewhere on the network. So it opens a lot of possibilities. The real contra is that you have to install Olama separately, and you have to run it at the moment separately. Yeah, and how does it look like? So that's what I just said. So yeah, I want to start the SSH server, and then I get exactly the command what I have to run. That's a relatively old example. It's, I think, 3 or 4 weeks old. Yeah, and then what I really need is help, and especially here, I need requests. So I just, the thing I'm always using is I want to install Vim. What I really need from you, from the audience, is what other tasks would you like to ask Kowalski? So what could be done? What's possible here? Because I just think in the small task I'm doing always, and I fail, but I would also really need your help to see what other tasks you would like the LLM to fulfill, and then I can run this task in an evaluation and see which model I have to choose, which embedding is the best, where to add more documentation, and so on. And it really just needs a name for the task you have and the prompt, what you want, the question you want to ask. And also, it's an open source project. Help is always welcome. So I'm just a single person. If there's more, then it will be really great. Yeah. If you want to compile it from the source, at the moment, I have one dependency, that's this Python face devil. That's this library where I can search in this high-dimensional vector space. At the moment, then you just have to build it. Since yesterday, I also got an RPM package for, I hope, just for many. I don't know. I just checked, I think, the Tumbleweed one, but it should also be available for 15.6 and 16.0. And you get it there from the Science Machine Learning repo. That's the last, one of the last slides. One thing when we get into this is the main problem here is how do we as OpenSUSE and SUSE treat LLMs in the future? So because the LLMs are available, so from the license perspective, that's really no problem because we get some LLMs with relatively good license like MIT or Apache 2, which we without any problem can distribute. But the thing is an LLM just a binary blob? So what do we decide, or what do our managers decide? Are we allowed to distribute them or not? Should we do that? Should we do that not? I don't know. Because it's not really a source. There's no chance that you can build an LLM on your own. You can use it. You can fine-tune it even. But create it from the scratch like you could do with the operating system, that's simply, you can compile a Linux kernel, but you cannot train an LLM. Yeah. And the other thing, it's this embedding creation. I need these embeddings to search the documentation in a proper way, and that's compute expensive. So creating the embedding for the task, that's easy because even if it takes a second, I don't care. But if you are reading in 1,000 documents, then it's 1,000 seconds. And for the complete documentation, that's really expensive. At the moment, and I think I will stay that way, I will just do it on a GitHub runner, which means that GitHub pays the bill or Microsoft pays the bill for getting these embeddings. I also relatively, I don't have to care about where do I get embedding model. If I would run it in OBS, I would have to take that, solve that task, like of finding out if I'm allowed to do that. If I'm just having on a GitHub runner, I'm just downloading it and I'm done. So I'm creating these embeddings at the moment there. Yeah, and that's it. Thank you for your attention. Are there any questions? No, Jim doesn't want to ask.
Hello.
Yeah, hello.
My question is, what documentation is included in the embeddings?
The SUSE reference documentation.
No knowledge base, TADs?
I would like to get the knowledge base and also more, but it's work in progress.
Okay.
And the knowledge base, the problem there was, unfortunately, it's not easy to get it. I would like to get it because I think that's a really valuable document source of information. Yeah, but here that's now. The thing is, to be sorry, I did not really solve it. You can just run it at root, the RPM package at the moment, because the database is only accessible for root and the Go library wants to write to it. So, yeah, but that is just a thing to be solved. Yeah.
Okay. And you asked for use cases.
Yeah.
I'm from the support team.
Yeah.
And we are trying hard to have a similar approach with reference to the support configs provided by the customer in order to analyze the content of a support config and try to have a first understanding of what is going on the system. Do you think Kowalski can help us?
Yeah, I hope so.
Okay.
That
Great.
would be great if we work together. So it's a project. It's really just a new project. It's at the moment it's more or less just the framework and the concept how to do this. I'm relatively open to find the right use cases. So it's yeah.
Okay. Thanks.
Yeah,
Ping
yeah,
you later.
we'll speak
Thanks.
afterwards. Yeah.
What is the intended deployment scenario of this? Is this meant to run as a local service or as a web service? Because LLMs are, of course, relatively resource intensive to run inference on.
It's intended really to run as a local service because if you want to configure your system, you do not want that information to be somewhere on the internet. And if you are running it from, if you're sending this information as a web service, it's not the best thing. And it's so at least Kowalski itself has to run on the local machine to get access or at least get an SSH connection to the machine you want to configure or you want to get information from. So there it's really local. The Olama instance could, for example, run in your institution, company, home lab on another machine, but it's really intended to run locally. And we can choose relatively small models which are relatively fast because we from the LL. So if you, for example, ask ChatGPT, it does not do that kind of documentation extraction because it knows it intrinsically, and that's not the point where I want to go. I want to say, okay, I want to use the reasoning capabilities of an LLM and not its intrinsic knowledge. You get the point?
Oh yeah, of course.
Okay.
That means you are embedding the information from the documentation in the prompt for the LLM.
Right.
But you're also including local information from config files.
Yep.
And is this already implemented?
Yep.
Interesting. Can you shine some light on which config files you currently include?
No, that I'm passing the documentation and I'm getting, so when I get the documentation, which is near the task, and it contains for example, it says, okay, you have to check etcresolve.conf, then I'm reading out etcresolve.conf. I just cannot show you here at the moment because I did not really prepare, but I'm really, so you can run these evaluations and then you see what the context is the LLM is getting, and that's the next thing I really want to work on to get there more insight what the documentation has as references to files, that we get there as much out as possible.
One final question. Which LLMs have you been testing on so far?
I think Gamma, the newest IBM model, then the one from DeepSeek, and also Gwen and the other ones. But it's really configurable because I just say, Olama, yeah, use that one, use this one, and I'm done. That's the reason why I'm really stick here to Olama at the moment. And I will, I think, always stay there because the LLM should always be interchangeable.
Okay, thank you.
No problem. Thank you.
So I think you mostly answered my question, but I've asked more specific. So
yeah.
Does Kowalski have the context of the local host? So not only does it read the documentation, but is it able to read config files on the fly and okay, so it can provide specific configuration suggestions for your host.
Yeah.
Okay.
I'm not there, so I don't know if the parser gets that out all correctly, but that's the thing. That's the goal, and that I can be sure. It's not just I also want to. You don't see it in that window, but I also want to make sure that you get here. If you ask a question, that it would say, okay, somewhere here it says here, okay, I access that and that files. Yeah.
Okay. I would also suggest it might be useful if we could access Kowalski through like an API. So I could provide a tool. So, for example, that where my tool is for configuring PAM, for example. This is the example I'm thinking of. Is I could say, or just supply to Kowalski, I need to configure PAM for this user for this particular PAM module. And will you read the PAM stack and explain to the user how to do it correctly?
Yeah, that's definitely the thing. If it's in the documentation, it should be able to do that. I'm still not knowing what's possible to do because I just think in these 4 simple questions I come up. I don't know what's really in the documentation right now. Yeah.
Okay.
Hello. This got me thinking. We had a little crisis trying to revamp the welcome application for OpenSUSE.
Yeah.
And if we could scale this down, you said like if we could have like decreased precision and still good enough, like I'm thinking, would it be like small enough to fit like on pretty much every box, maybe not necessarily by default, to get you like basic hints on the system? Like,
Yeah.
this is where get.
So it's really running locally on my laptop, and it's not.
I know. And I'm really thinking, why don't we actually reconsider welcome application? And if we have this available on certain image, like let's just use that as a welcome, like a little prompt with bubble, and like what do you want to do? Do you want docs? Do you want to file issue?
It's still slow, so the questions here always took 1 minute to get the answer.
Okay. Yeah, but like maybe we could start experimenting it, and in 5 years make it happen. Something like that. That would be cool. Thank you.
Yeah, no problem.
Just one more question. You said that you can add the config file and on the fly feed them to Kowalski. Is it the same also for the log files? For the local log files, I mean.
I have that in the back of my mind. I don't know how to. I just did not write anything yet, a retriever for the log files, but that's definitely a thing. So if I don't know how the documentation mentions the log files and how this is then helpful, but perhaps there, or just for example, if you see a comment or a service in the task, you could simply pass the task and say, okay, this has a reference to a service. Then I could, for example, filter out the last 10 log messages of this.
Okay, thanks.
Last question.
Last question, Jim says.
What happens if the written comment fails? Is there any second phase for verification?
Not yet.
And is it planned?
Perhaps. Yeah, it's kind of, I'm always, for example, I don't store that conversation as a context. That would also be useful. So, okay, the task failed, feedback the information why it failed. But yeah.
Okay, thank you.
Thank you.